Okay, here are your notes on charging methods, and this is the last big topic in our electrostatics unit. Okay, you know that all matter is made of atoms, and you also know that atoms have protons and neutrons in the middle, so the middle part is charged positively, and the electrons are in what they call orbitals, different orbitals around the nucleus, and the electrons are negatively charged. But the overall charge of the atom is neutral because if you have 2 plus and 2 minus or whatever, they're always the same number of electrons as there are protons because I mean not always, but I mean usually because most atoms, most matter is neutrally charged, right? So if an atom loses an electron, it becomes positively charged. If it gains an extra electron, it can become negatively charged. And that's called ionization. You probably learned about that in chemistry. Um, so you can get, and some materials tend to give up electrons pretty easily, and some materials tend to accept more extra electrons pretty easily. And so the overall charge of certain materials can become like a little bit extra positive or a little extra negative. It's not like it's all positive because you're not going to get rid of all the electrons. And it's not like it's all negative. I mean, you still got a bunch of protons, but you just have some extra negative electrons. So we're talking about the extra charge, like we did in the Coulomb's law balloon lab. We're talking about excess charge, either extra plus negatives or a lack of negative electrons. The protons don't move. So there are two basic types of electrostatic materials. Either they're insulating or they're conducting. And insulators are like pretty much everything that's not metal or water. Um, so glass, plastic, ceramic, rubber, wood, fabric, wool, cork, paper, they're all insulators because wherever you put extra charge on an insulator, it just stays where you put it. So if you rub some plastic, which I'll do in the next video, where you rubbed is now going to be charged, and it might be positive or negative depending on whether the plastic accepted electrons or gave up electrons. But the rubbing tends to kind of scrape electrons onto the thing that prefers more electrons and takes them off the material that's willing to give up electrons. So that's insulator. So you can charge insulators. It's just that the extra charge doesn't flow, doesn't move. Conductors, you can charge just by touching with some extra charge, and that extra charge will flow through the metal. They're all metal, or else water's the other good conductor. And so you can conduct electricity, right? So that's what circuit wires are made of, metal. And when you put charge on a conductor, if let's say you put a whole bunch of excess charge like right here on this piece of this metal, as soon as you put it on, let's say it's all negative charge. Negative charges don't like each other, so if they can, they'll move apart. And because charge can flow through a conductor, those negative charges will spread as far apart from each other as they can, and they'll spread out. So the whole thing will become negatively charged, and that's the way conductors work. Insulators, it stays in one place. Conductors, the excess charge can flow. Okay, so another vocabulary word is when you polarize. Something that's polar, um, it's not actually overall charged at all. It's neutral, but the positive and negative charges are distributed on either end, and you probably learned about this in chemistry. So when you make it polar, you polarize it. That's just vocabulary. Another vocabulary, a ground. In the classroom, we would use the classroom faucets, just like some big metal thing that you can touch and then extra charge will flow there. That's what a ground is. So in your house, usually your electrical wires the ground is connected to some water pipes or something to ground them. Okay, so that's the vocabulary for ground. It's a large reservoir of charge, so that if you put some extra charge on it, the extra charge will flow into it. And it'll still stay overall neutral just because it's so big. The ground is really, really big, has a lot of charge, and so a little bit of extra charge is just going to flow around and not significantly change the charge of the ground, but it will discharge. Whatever charge wants to leave this thing will go onto there. So a couple of different ways that you can charge things, and this is what you're going to look at in the charging methods demo lab that you're going to do next. Charging by conduction is just, well, this is only with conductors, because you take one metal thing that's, let's say this conductor is positively charged, and you touch another conductor to it. The positive charges, well, positive charges actually don't flow. It's electrons flowing, but let's just for a minute think that they're positive charges that can flow. The other metal touches it. Positive charges don't want to be near each other, so they flow over to the other one, and now both metal objects are positively charged. Now this makes it look like they have more than they started with, but it should be the same total excess charge, and it's split on both of them. And then when you take them apart, now they're both charged. Now what's really happening is not that positive charges are flowing from here to here, because the protons don't move. What's happening is that the electrons on here are flowing over to here, and when that happens, what's left is positive. And not all the electrons flow, so this is still going to be excess positive. It's just going to be a little bit less positive. So this picture is a little misleading, because this looks like it's the same positive as the original, but it's probably half. It would be half the amount of charge, because it's split between two. Okay, the second charging method is called separation of charge. This is a way to charge insulators, like a balloon. Yeah, let me show you an example of that. Here's a FET simulation. We've looked at FET simulations before. And I'm going to take the balloon, which is neutrally charged, right? You've got as many pluses as you have minuses. Same with the sweater. But if you rub the balloon on the sweater, the balloon tends to collect negative charge, and the sweater tends to collect positive charge. And now they're attracted to each other, because negatives attract positives. Also, the balloon is attracted to the wall. Look what happens to the negative charges in the wall when I bring it close. You can see they move away from the extra negative charge on the balloon, and therefore now you've got pluses and negatives attracting each other, and so the balloon is actually attracted to the wall. And this is why, even though the wall isn't charged, it's still attracted to the charged balloon. It's because of this motion of the electrons moving away, so that the pluses are the closer charge, and now you have this, now you actually have like a charged region here of plus charge. This is why uncharged objects are still attracted to charged objects. And this is why you could take this balloon and like pick up little bits of paper with it or something, even though the papers have no charge on them. Uncharged objects are attracted to charged objects. Here's another FET simulation. It's called John Travoltage. And you can rub his foot on the carpet, which charges him. And then he's going to be now negatively charged. And when he moves his hand near the doorknob, you can see that negative charge wants to leave him and go to the doorknob, which is kind of like a ground in this case, right? It's got some metal there, and it's a place for that extra charge to leave him and go spread away. Negative charge doesn't like to be with negative charge, so it's going to try to spread out if it can onto that ground of the doorknob. He's going to get grounded that way. Okay, so the balloon rubbed on the sweater, and John Travoltage rubbing his foot on the carpet, his rubber shoe on the carpet. Both of those are examples of separation of charge with insulators. That happens with insulators. Okay, so the next charging method is induction with grounding. And induction is the same for our purposes as polarization. and it's where you separate the charge on a neutral object. So here, for example, here's a neutral plus, as many pluses as there are minuses. But this negatively charged thing comes near it, and now the pluses move to the right and the negatives move to the left. We're going to assume this must be a conductor. And so that's called induction. But you can see this is still neutral. It's just polarized. But if while it's polarized, you ground one side, the side with the charge that would like to leave and get further away from this negative charge. So this negative side, if you ground it with this big ground where the negative charge can flow away, now you're left with more positive than negative, and this is now a net positively charged object. So there, you can actually charge it this way by induction with grounding. That's what it's called, and that's charging method number 3. And so those are the steps. All right. And then finally, I just want to mention this device called an electroscope, which I'll show you in the Charging Methods lab video. This is an old device for determining whether something is charged, and I think they even used it to determine radioactivity as well. But if they touch this ball to something and it got charge on it, this is all conductor, all metal, then the two metal leaves would have the same charge. Maybe let's say it all gets positively charged. And you could think of positive charge flowing onto it, but really what happens, of course, is negative charge flowing off. Electrons are what flow. And so let's say the leaves are both positively charged, then they will repel each other and you'll see them move apart. And that was the way that people used it. So you can charge it by touching it. You could also charge it by induction. In that case, it's still overall neutral, but you can get the pluses to go down and the minuses to go up, or vice versa. And you can also charge it by induction with grounding, like I just showed in the other thing. You would bring it near a charged object and then touch it to a ground. Could be just your finger, could be a good ground. And then that will remove the charge that wants to leave, and you're going to be left with an overall net charge. Okay, so that's your notes on different charging methods. Now you should watch the video for the Charging Methods lab, where I do a bunch of these different kinds of charging methods, and then you can fill out write up the lab, and it's not a form. There's just a sheet that explains what questions you should answer. Okay, all right, have fun.